Hello, welcome back to the Celestial Wheel. I'm Chief Simpson, and we're going to be talking about a day's work in navigation. Now, you have the day's work in navigation checklist there. It's already in the nav dorm, and the ships can tailor it to make it fit your watch teams better. But no one has ever really illustrated it. So that's what I'm going to do today. I'm going to illustrate what a day's work, at least the day's part of navigation looks like. All right, got a blank slate right here, and I'm just going to draw a line straight down the middle. That represents a celestial day, the day part of it. Okay, I'm going to go ahead, get the middle all the way from the top all the way to the bottom, and I put that there for a reason. I'll get to it here soon. When I say that there's checklists in your nav dorm, it basically tells you what watch should do what task for a day's work in navigation. Now that we're part of the circadian rhythm, a lot of watches, you basically have 2 watches a day, at least what I've seen going on in inspected ships. You have 2 3-hour watches a day. That way you get adequate sleep at night. So each watch will have to do a certain things with day's work in navigation. And that one watch has to do something, what they're supposed to do, because it will mess up the next watch's celestial times. For example, if they don't get any sun lines in the morning, they have nothing to advance to the next sun line so they know where they'll possibly be. They'll have to wait till the 12 o'clock or the local apparent noon fix to actually get their position. And you just wasted at least a quarter of a day's work in navigation right there. So everyone has to do their part. So I got my 2 lines. Like I said, this blue line right here represents the celestial day, the day part. And I'm going to draw lines right here, and I'm going to do a dotted line here. And I'm going to do a mirror image on this side. Before the sun rises, we have this thing called twilight. We have 2 different types of twilights that the Navy recognizes. We have nautical twilight and we have civil twilight. So drawing these lines right here, we have to find out twilight times by calculating it from the Nautical Almanac so we know what time to see our stars, where they'll be their brightest and which ones we actually need to triangulate our position. Nautical twilight is first. It's when the sun is about 12 degrees below the horizon, and I'll just write nautical right here. The next one is when the sun is 6 degrees below the horizon, and that is civil twilight. In between these 2 right here is when you want to try to find your stars. I can't draw a star to save my life, and possibly a planet. You get 3 stars, a planet, you get your fix started, and then you can DR out to your next sun line. After you get your fix, next thing you're going to do when the sun is about, well, you have sunrise. And sunrise is when you see first light, when the top part of that, the upper limit of that sun peeks through the horizon, and you actually start to see the actual yellowness of the sun. When the sun goes up a little bit more, about 2/3 of its diameter above the horizon, you can shoot a bearing to it using an alidade. And that bearing you get, do a simple calculations, which we'll have a video up here soon, and it's called amplitude. You get gyro error from an amplitude of the sun. And I just draw right amp right there. All right, your celestial day is just getting started. I would say around 0800, and I'm going to say that with a grain of salt because everyone's times are a little bit different. And I'll put a little squiggle right there for about. Draw the sun right there. Take your first sun line. Either put your sun line in Stella, you'll put it in Stella. Try to calculate it using the strip forms from one of the videos on here. and plot it out on a universal plotting sheet, see how you do. To try to get something to connect with it, take one of the star lines that you did and advance it up to that sun line. That way you get an estimated position, and hopefully it's on your DR. Once you have that DR out, that way you'll be ready for your next sun line. This dotted line right here, I'll draw another sun. When the sun's about 45 degrees, or visually 45 degrees, or around 9 o'clock, try for your first azimuth of the sun. Azimuth of the sun is another way of getting gyro error. Do it in Stella, just get the bearing from it using your azimuth circle. And with the sun being about 45 degrees, you don't have to yank that mirror all the way back or all the way forward to try to find a glare from this to reflect. Get your azimuth, compare it to the gyro error you got with your amplitude. If it's the same, you don't have to change anything. If it's different, update your repeaters. All right, draw another sun right here. That'll be your second sun line. It'll say that around 1000, give or take. Then you can advance the first sun line up to that sun line. They start to intersect. You have a estimated position. Now, before I keep going, since we have two sun lines now, according to Bowditch, the big thick book that we have, and a lot of people fall asleep reading it because I try to read it at night, Bowditch says two lines of positions intersecting each other is a fix. But we're in the United States Navy. The Navy makes you add that next LOP to have a more accurate fix, and that's what you call a fix. They will call this an estimated position. So technically, when you go to get your local apparent noon, which we'll talk about here in a second, that will be your third sun line, and then you'll have your fix at noon. Take that one with a grain of salt. Don't argue with your seniors on that. It's just what Bowditch says. All right, right around noon, give or take plus or minus 10 minutes before noon or after noon, 10 to 15 minutes, the sun should be at its peak before it starts setting. That is land, local apparent noon. That will be your third sun line for the day. You can advance both of those to there. Hopefully it's right on top of your DR. Could be off a little bit, but the wonders of local apparent noon, you can find your exact position using local apparent noon. You have a simple formula. Once you get your zenith distance, which is the 90 minus HO, plus or minus your declination, depending on where you are in the world, you get your latitude. Now, if you get the sun's peak, and it's not a little bit over, a little bit before, right at its peak, that is GHA. Your GHA will equal your longitude. And then you'll just plot it. Another cool thing about the sun line that you get with local apparent noon, it's a straight line right across either your Stella or your universal plotting sheet. It's a straight line. You're going straight to the latitude that it's supposed to be. And you can use it for, like I said, just getting your position or as a sun line with the other ones. Everything that we just did over here is mirror image over here. You have suns right here, sun line, another azimuth, sun line, give or take, say this is like 1400, 1600, 1900, give or take at what time sunset is. Hopefully, it might want to go a little bit higher than that. 17, 15. Do another amplitude. And then you got civil and nautical twilight again. Now, the one thing with these sun lines, star fixes, and all that, you need the sextant. You need to know how to read the sextant. And two, you need sight reduction tables so you can actually sight reduce these down. And 3, you need a crisp horizon. Now, at night, it gets a little iffy, especially if it's pitch black darkness. You won't be able to tell the difference between the horizon and the sky. With that problem, a DR would probably be more accurate than just trying to do that. I would say still try, because the worst thing that can happen, your star line would be inaccurate. You just won't plot it. You just go off the DR. You DR throughout the night, and it just starts right over the next day. So that's illustrating a day's work in navigation. It's not everything that's on that checklist that's in the NavDorm. It's just a crude drawing of it, and hopefully it makes sense to you. So if you like this type of content, give the video a like, consider subscribing to the Celestial Wheel.